Which alkene is most reactive in an electrophilic addition reaction? So the alkene that is the most reactive is going to be the alkene that has the lowest activation energy barrier, or EA. And the height of that activation energy barrier is going to depend on the stability of the intermediate. And so the one that has the lowest activation energy barrier is going to be the alkene that can form the most stable intermediate. And if we are talking about an electrophilic addition reaction, the intermediate that we are talking about is a carbocation. So we're looking for the alkene that can form the most stable carbocation. And so we should remember things that stabilize carbocations: substitution and resonance. And of these two, particularly when you're dealing with dienes, we're going to really focus in on resonance first, and then we'll look at substitution. And since we're focused on resonance, what I would do immediately looking at this is I would notice that alkenes C and D are isolated. So you cannot have any resonance stabilization here. So I won't even consider options C or D. And so that brings me to looking at the conjugated alkenes A and B. And what I would notice immediately, right, when we're protonating either one of these, we need to protonate to get the allylic cation. So we're specifically looking for allylic cations, because those will be the ones that are resonance stabilized. And so what I would notice is that if I protonate A, I would put a hydrogen out here. I would get a carbocation here where it's resonance stabilized by the alkene B, and it's also tertiary. I'm going to draw the resonance structures to check, but noticing that I could form a tertiary allylic carbocation from A, if I was running short on time and had to guess, I would guess A. But let's take a look at the different pathways. So I am going to redraw this molecule. And I am not going to bother redrawing the whole chain. I'm ignoring that. I'll just make that R. And so if I was adding a proton source to alkene A, I would form the following carbocation. So I would form this tertiary allylic cation. And the resonance structure for that would be the following. Which is a secondary allylic cation. And it's important to draw both of those resonance forms because your overall carbocation will be an average really of those two, spending a little bit more time or a little bit more similar to that tertiary allylic carbocation. This looks fairly stable, but for comparison, let's take a quick look at B. All right, so if I protonate that alkene B, right, here's where I need to really think about resonance and recognize my hydrogen is going to go here to give me the resonance stabilized carbocation. A resonance stabilized secondary carbocation is more stable than just a secondary carbocation. So I have that secondary allylic cation. And if I draw the resonance form for this, it looks like I'm going to get another secondary allylic cation. And so what that tells me overall is that that first guess I took for A was right. That is our most reactive alkene because we have the most stable carbocation intermediate.